Okay, welcome to the lesson. In this presentation, we want to look at the shooting method. All right, I must be quick to mention that this presentation is meant for university students. So the content may not be suitable for high school learners. All right. With that said, let's look at shooting method. All right. Now, in general, when you talk about shooting method, it is a method that uses the concept of trial and error, right, to solve a particular differential equation. All right. In most cases, you try two guesses and you may not be able to get the solution. So you combine the results from the two guesses to come up with your initial guess that you may use now to execute the problem. All right. So there are a number of steps that have to be undertaken in order for you to be able to solve that. Okay. So I'll try by all means to explain these steps through this question. Okay. So let's look at the question. We are saying a steady state heat. All right. A steady state heat balance for a 10-meter rod can be modeled as dt squared to dx squared minus 0.15 t is equal to 0, such that t of 0 is 240 and t of 10 is 150. So you need to understand from these boundary conditions that our 0 here is our lower boundary, then the 10 here is our upper boundary. Okay. Now the question is, use the linear shooting method to solve this equation, assuming a step size of 5 meters and the initial guesses of z naught is equal to negative 120 and z naught is equal to negative 60. All right. So let's look at our solution. The starting point in resolving this problem is to look at the data that we have. So we have our differential equation given as please take note. Yeah, it's supposed to be like that. Yeah. So we have the 2t divided by dx squared minus 0.15 t. This is what we have, and that this is equal to 0. What else do we have? We have been told that t of 0 is 240, and that t of 10 is 150. We have also been given the h, which we call the step size. So the h is equal to 5, and that our initial guesses are negative 120 and negative 60. So the first step in resolving this problem is to discretize the interval. So we'll say discretization. All right, we discretize the interval. Now, if you want to know how many intervals we are supposed to have, you can use h is equal to b minus a divided by n, where n is the number of intervals. In this case, our h is 5, our upper boundary is 10, the lower boundary is 0 divided by n. Therefore, you realize that your n will be 2. So we only have 2 intervals. All right. So now let's proceed with our discretization. So we are going to have x naught, x1, and x2, all right? So x1 is 5, x2 must be 10. That is the boundary, is 10. I is equal to 0, 1, 2, all right? So for this shooting method, when calculating, we take I to be 0, 1. We cannot get 2 because it's going to overlap. When we use the Euler's formula, it will overlap. So we only get 0 and 1. All right? Now, we are going to do some manipulation to our differential equation. Note that we have the 2t divided by the x squared minus 0.15t, and that this is equal to 0. All right? So we can rewrite this as d squared t divided by the x squared. This will be equal to 0.15 t, and this is the same as fx comma t comma dt dx. All right? Now, from here, maybe we can say let part of this, that is dt dx, bz, just for argument's sake, let's say, what does it mean? So dt dx is equal to z will be our f1. So f1 will be equal to x comma t. Now, this z, we are saying it is this. So this part here, we'll just put z. All right? And this should be applied on the initial condition. On the initial, on the lower boundary, in short, which is t of 0 is equal to 20, 240, then x naught is 0. All right? Now, if we've said that dt dx is z or z, substituting or replacing in here, this becomes dz dx squared. All right. What does it mean? It is this. So this will be equal to 0.15 t, right? And this is the F2. So when it comes to F1 and F2, always refer to these formulas. So this will be X, T, and the Z. This is what we have. All right? For I is equal to 0 and 1. All right. So from here now, we pick our initial cases. And take note that in this case, here, we'll use our initial guess Z naught, which is the same as is equal to negative 120, which is given. Our Z naught here is negative 120. That is our initial. So we are saying our initial guess, we can even write it here. So this is a very simple process. But as you do it for the first time, it may look to be difficult, but you need to do it on a number of times. You realize it's a very simple process. All right, it's simply iterations that we are going to be doing. So our initial guesses, we are going to pick x naught is equal to 0. Then t naught, it is 240, the given one. This is what is given. This is given. Then z naught, we are picking negative 120. This is our own initial guess. Now, from here, you need to understand the Euler's methods. Others will say Euler's formula, but I'll call it Euler's method. Now, because we're dealing with the t, so the first method will be ti plus 1 is equal to ti plus f1 xi, comma ti, comma zi times c, the step size. Number 2, we have zi plus 1 is equal to zi plus f1 xi ti zi plus h. All right. So now, we are going to take our I to be equal to 0. What does it mean? When you replace here where there's I, you put 0, it means 1 becomes T1 is equal to T naught plus F1, open bracket, X naught, comma, T naught, comma, Z naught times H. We do the substitution. What is our T naught? From our guess, we have 240. 240 plus F1, our X naught is 0, 240. Then our Z naught is negative 120. Negative 120. Our step size is 5. I hope that is fine. I hope that is okay. All right, so what that means now is to find T1, you maintain your 240 plus, you multiply inside here, you multiply the Zi, right, times the step size. This is what we do here. So in this case, we're talking about Z naught multiplied by 5. So what is our Z naught? Our Z naught is negative 120 multiplied by 5. All right? So we are going to get 240 minus 600. And when you compute, you'll be able to get negative 360. This is our T1. All right? Now, meaning that 2 will become Z1, Z2 plus, take note, Z0, not Z2, Z0. F2, X0, T0, Z0 times our step size. So our Z0 from this is negative 120 plus F2, our X0 is 0, negative 120. Please take note, this is 240. Yeah, that's a problem with the shooting method. And a slight mistake, then there's a problem. So 240, negative 120 by 5. So negative 120 plus F2. If we were to go back, you look at F2. We said F2 is this. All right? So we are going to have 0.15 T times 5. But our T here, it is T naught. And our T naught is 240. So here we put 240. All right. So when you work out this one, you multiply 0.15 by 240 by 5. You're going to get 180. 180 minus 120, you'll be able to get 60. So this is our Z1. Now, what will be our X1? It means X1 is equal to 5. Where are we picking this 5? From our discretized interval. Here, our X1 here is 5. Our X2 is 10. Now, so now we use I is equal to 1. So when I is equal to 1, what do we get? All right. So it's the same process, right? It means the Euler's method for the first formula becomes T2. All right? Becomes T2, which is equal to T1 plus F1, X1, T1, Z1 times H. And what is our T1? T1 is what we have calculated above, negative 360. All right? So you have negative 360 plus F1. What is our X0? X1. Our X1 is 5. T1, negative 360. Z1 is the one that we've calculated here, 60. All right? Times 5. So repeating the same process, repeating the procedures above. So we have 60 by 5. All right? Z by H. And when you do that, what do you get? So you're going to get 300 here. Negative 360 plus 300, we're going to get negative 60. This is T2. T2 is our boundary. So the boundary must be equal to the value of T10. T10, which is this. But they are not the same. So it means this solution is not correct. Or the guess that we use, Z0 is equal to negative 120 is not correct. All right? So this is not equal to T10, which is equal to what? 150. These are not the same. If you want, you can go on and get Z2 and X2, which will be 10. But for me, this is sufficient because for the upper boundary, I've already discovered that it is negative 60 using Z0 of negative 120, which is not equal to that. All right? Therefore, we pick another or the second case. That is Z0 is equal to negative 60, and this is given from the question. Then we repeat the process, all right? Now, when I is equal to 0, meaning that 1 becomes T1 is equal to T0 plus F1, X0, T0, Z0 times 5. What is our T0? 240, all right? Plus F1, our X0 will be 0, T0 is 240. You may be wondering, where are we picking this? It's from this. The only change now is here that we're using a 60. Okay. The only change is that we're using a 60. And take note that this initial guess that we have used, we can call it actually the G1. Okay. Then this solution that we have found here, after applying the initial guess, the solution for negative 60, take note here, I'll say R1 is negative 60 because we'll use this to extrapolate the results through the interpolation formula. All right. So our Z naught, now we are using negative 60 times 5. Please here demonstrate into substituting. All right, so now we have 240 plus F, right? We can actually now get the actual value. So we'll have negative 60 times 5. This is what we have, right? So when you do that, what do you get? You get 300, negative 300 here, plus 240. Our answer becomes negative 60. This is T1. We go to the second equation, Z1. I'm trying to use maybe a good color. So Z1 is equal to same process. So to be Z naught plus F2 X naught T naught Z naught times the height. Not necessarily the height, but the step size. All right. So in this case, what is our Z naught? Our Z naught is negative 60 plus F2 X naught. We are still at I is equal to 0. So X naught is 0. This is 240 as in the case above. Then negative 60 multiplied by 5. So we know that this will be negative 60 plus Z times the step size. So negative 60 times 5. All right. So when you work this out, what do we get? The final answer, upon your computation, we are going to get 120. Okay. 100. Please take notes. Maybe we left out something. For Z naught, mind you, for F2 is 0.15 H. So this is 0.15 times. Actually, in the equation, it is T. So our T is the T naught, which is 240. Then it is this value that should be multiplied by 5. And when you do that, you multiply 0.15 by 240 by 5 minus 60, you eventually get 120. That's what I got with my calculator here. All right? Take note again, this is I is equal to 0. So we do for I is equal to 1. So when I is equal to 1, meaning that equation Roman numeral 1, what are we going to have? We're going to have T1, T naught plus F1, X naught, T naught, Z naught times H. Our T naught remains. Our T naught remains to be 240. All right. So our T naught remains to be 240. Okay. So in this case, we have 240 plus F1, our X naught. Our X naught will be 0, 240. Then our Z naught, we're using negative 60 this time around, times the step size, which is that. All right. I hope this is okay. I hope it is clear. So you may pause, try to work it out. Let's see what you're going to get. Take note, because we are saying I is 1, so this is T2. This is T2. Therefore, this should be T1. We need to make those adjustments. So, yeah, even in an exam, you can easily mess up things, all right? So, this is T1. This is what we have. So, we are going to get these values from our previous calculations. So, our T1, if you check from here, is negative 60. So, we have negative 60. Our X1 now becomes 5. Negative 60. Then our Z1 is from our calculation. Our Z1 here is 120, and X1 from our interval there is 5. So 120. Meaning therefore that we have negative 60 plus 120 multiplied by 5. So when you work it out, you're going to get T2, which is equal to 540, and that this is not equal to 150. Therefore, our second solution, R2, is equal to 540. Now, if you want, you can get Z2. Following the same process, should be able to get 75. But we can only conclude even with that. That is insufficient, T2, because it's not equal to 150. Therefore, we need to combine the results from Z naught of negative 120 and Z naught of negative 60. So maybe we can say the summary of the results so far. Of the results, that our first guess was negative 120. Then our second guess, which is G2, is negative 60. Our first solution from now that our first T2, our first T2 was negative 60. Then our second T2 is 540. All right. Then there's also need of what we call D, which is 150. D is the solution that we are targeting, and we are targeting 150. So now, because using Z naught of 120 and Z naught of negative 160, we are unable to get 150. We are going to combine these two guesses and come up with our new Z naught by the interpolation formula, all right? So say, therefore, our Z naught, the new Z naught that we're going to use, apart from what we were given now, those two that we have been given are failed. So we combine their results, right? So we are going to say, this is guess one, the first guess plus the second guess minus the first guess divided by second result minus the first result multiplied by D, our target, minus the first result. So what does this imply? Our Z naught will be equal to, what is our first guess from what were found? It's negative 120. Plus our second guess is negative 60 minus negative 120, so to be plus 120. Our second root or result is 540 minus negative 60, so we have plus 60. Times our D is our target, 150, minus negative 60, so the plus 60. All right. So when we work out this, it turns out that our Z naught will be negative 99. So this is the new guess that we are using now, and follow through the same process. The process is tedious, especially when you have a lot of intervals, all right? When your N is big, all right? So what does it mean now? It means our initial guess, or we just say our guess now. What are we going to have? We'll say X naught is 0, T naught will remain as 240, then Z naught, we are using the new Z naught, which is negative 99. Then find the solution now when I is 0. Meaning that one, the first equation from the Euler's method will be T1 T naught plus F1 X naught T naught Z naught times our step size. All right? So in this case, what is our T naught? 240 plus F1, our X naught is 0, 240 negative 99 by our step size is 5. So 240 plus Z times the step size, negative 99 by 5. So when we work out this one, what do we get? We'll get negative 255. All right. Then we can get Z1. So Z1, when I is 0, it will be Z naught plus F2, X naught, T naught, Z naught times the step size. What does this mean? Our Z naught is negative 99 plus F2. Our X naught is 0. Our T naught is 240. Then negative 99 multiplied by our step size, which is a 5. So we'll have negative 99 plus 0.15 T times 5. But this T is our T naught, and our T naught is 240, right? So multiply this by 240. All right. And when you do this, what are we going to get? We are going to get 81. We'll get 81, and therefore our X1 is equal to 5. So now we compute the value or the values when I is 1. So when I is equal to 1, I only get t here. So we're going to have T2 is equal to T1 plus F1, X1, T1, Z1 times H. So our T1 is from what we've calculated. Negative 255 plus F1, our X1 is 5, our T1 negative 255, comma, our Z1 is 81 times 5. So what we get, negative 255 plus Z times H, 81 by 5. All right. And when you compute this, finally, we get our solution, the desired solution, which is 150. And this is equal to T of what? 10, which is 150. And that is our solution. If we want to conclude, we can say, therefore, T1 is equal to our T1, what did we get? Negative 255. Then our T2 is equal to 150. T naught, if you want, is 240. This T1 is the same as T of 1, which is equal to negative 255. This T2 is the same as, all right, T of what? 2, which is the same as T of 10. And we get T 150. So that is our solution. So you can see that with a shooting method, just like in normal shooting, if you're targeting at shooting maybe at someone or at something, you may miss. You may need to do it a number of times. Trial and error. So from our 3 guesses, this is our final solution. Okay, so please, you may need to do it time and again for you to be familiar with this method. Otherwise, very easy to make mistakes, especially in an exam when you're under pressure. All right. But please subscribe to our channel, phiri-JM. JM and Chaomba Mbondo. Want to contact us, you can contact us on 0978 56 58 76. Till next time, bye-bye and God bless.